Hello everyone, good afternoon. In the last session, we have seen abstract classes and how we could use pure virtual functions to convert a regular class into a abstract class. And we saw how the hierarchical derivations help you to build applications. We saw single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, and we saw the problems associated. There was a question by Faisal. What happens if a protected member is derived into a class, and what happens to the private members of the class, which is a part of a class? So let's see the scenario in which the question was raised. So there was a class 3 with a private member index, and if you create another class 2 in which you have as a protected member the object of class 3. So this is the scenario, and if I derive another class 1 from class 2, what happens to this protected member and its private data members? So when you derive a protected member into another class, obviously the object becomes accessible here, but the object's private data members are not accessible. So as you can see, if I try to do object.x equal to something, you cannot access object x. All right. So the member variable in class 3, if it is protected or private, will not be accessible to the descendant class which are derived from class 2. All right. So we'll see a demonstration of this quickly. Uh, Here in my, so I have taken a real life example. Let us say we have a class engine and one of the protected member is engine number, and within the constructor of the engine class we have a initialization of the engine number. Now this class is going to be used in another class called car. So this is class 3, and in class 1, the car class, we have as protected member car color. It's a regular variable, whereas the second one is a reference variable of the engine class. So just observe that I'm using engine star E. So within the constructor of this class, I'm initializing anyway the car color inline initialization, but I need to initialize the member variable E through a new operator, and in the engine I have to pass the value of the engine number, let's say EZ, some number like that. Okay. However, you should have a parameterized constructor in the base class, which we have it here. Uh, the name of the class should have been just engine here. So now it works fine. Now we have made engine object as a protected data member of class. Now I take another class which is class 2 which derives from class 1, that is class Maruti car derives from car class. Now what happens in this class to the data members of the base class? Now in the display method I can readily display the car color. If I say car color, it is readily accessible. That's no problem. Whereas if I try to access the engine number, or even for that matter any data member which is there, which is not accessible here. If I say E arrow, nothing comes here. All right. So to access the protected or private data member, you should have a getter here. So I would write in the public space string get engine number. Okay, so you can make it read only and just say return engine number. So it should be a function. Now this you can access get engine number as a getter here, and you can put endl. All right. So the private data members of the objects which you make as a member of another class can be accessible only through a getter and also modifiable through a setter. So if I create an instance of Maruti car M, and if I say m dot display, it should go through easily. Now if I run the program, you will see the engine number will be displayed and the color of the car will be displayed. So red, EZ, whatever. Okay, so as you can see, we are able to access the protected data member of the object, which is a member of another class, only through a getter, not directly. You may argue that we can make it public, but the moment to make it public, it violates the principle of encapsulation. All right. So the way to get around this is put a getter in the third class, that is class engine, and use it appropriately wherever it is applicable. All right. Okay. So let's move on. Now we have seen polymorphism where the base class method uh, can be overridden by a subclass method using virtual keyword, and if whenever that happens we have a runtime polymorphism. But can I have something called as compile time polymorphism? So compile time polymorphism is possible only within the class. So let's say we have a class called as calculator, and in the public section, let's say we have three methods, add, or four methods. These four methods are all overloaded methods. It means the methods will have different data types, arguments of different data types. They should differ at least either in the type of arguments or the number of arguments. Since all these methods have same number of arguments, they should differ in the type of arguments in some way. So first method, as you can see, it is int x y. The second method differs in the second argument, that is first one is int x as in the first case, whereas the second argument is float y. Likewise, the third one, both are float, and in the last one, first one is double and second one is int. All right. So the return type can be different, but just the return type will not make the methods overloaded. They should definitely differ in the number of arguments or the type of arguments or the order of type of arguments. So I can create one instance of the calculator and execute these methods. So why it is called compile time polymorphism is that at compile time, the compiler is able to decide which instance of the add method it has to call depending on the arguments type. If you pass both integers, it will call the first add method because both arguments are int. And if I pass one integer and second float, as in the third case here, it will call the third one here. All right. So just see the demonstration of this with the example code, compile time polymorphism M. You have a calculator, and I will add a couple of add methods. First one will both have int x and int y, both of type int, and just say return x plus y. And I can vary the types by just altering the data types of the arguments. So I can have a couple of these methods. Let this one differ in the second argument float. This one, let it differ in the first argument double. So if whenever you make one of them float or double, the return type should also be correspondingly different. Float. Here also it should be double. So just by making the return type different, you cannot have overloaded methods. They should differ in the type of arguments or the number of arguments. So now if I create an instance of calculator C, and if I say C dot add, if I pass 5 comma 6, what should happen? It should give me 11 as the answer. As you can see, oh, I'm not printing this, so I should give a C out here. Yes, as you can see, 5 plus 6 is 11. Now, if I change the data type of second one, if I make it float 6.7, then see what happens. It knows exactly which add function to call. Now, this will not work because second 6.7 will be treated as double. So, there is no add function with second argument as double here. So to make this work, you had to put f here, explicitly specify the second argument is of type float, and this should work this time. As you can see, I have 11.7 as the answer. Similarly, if you want the third method to be called, this should be 5.6 and this should be integer, so it can be 6, just 6 like that. So this is again going to be 11.6. So the overloaded methods in a class, okay, they are compile time polymorphism. So this is what is compile time polymorphism. So now moving on further, there are a small finer points regarding the classes. That is, if I use a keyword final with the class, what happens? And if I use the same final keyword with the method, what happens? If I use a final keyword with the class, like the way I've indicated here, class test final, then no other class can derive from class test. That is, you cannot say class test one public test. This is not allowed, because once you make the class final, the class is breached. No inheritance is possible. However, if you want final control over the methods, then if you make a virtual method final, the subclass cannot override it. All right. So these two are very important provisions in a class. That is, using a final keyword with the class and final keyword with the method will have serious implications on the way you can use the class to derive or override the method that is in your class. So let's see the demonstration of the same. I have a base class here which has a display method which is virtual. Okay, and there is a derived class which is deriving from base class, and it is, let us say, overriding the method display, and it is displaying the I am derived method. Now if I create or use a base class reference variable to point to the subclass that is derived, this is perfectly fine. And if I say b arrow display, it should call the derived method implementation. It's a runtime polymorphism. Okay, so this works very well if you do not put any final keyword after the class. So but if you make this base class final, then you will get an error here. That is, base class is final and no other subclass can derive from it. Okay, so this is one implication of using final with the class name. But if I make this display function final, then there is no problem deriving from base class, but it will not allow you to override the virtual method. As you can see, you get an error here. Cannot override final method. However, if you have a normal method, uh, virtual method, let us say you have a virtual void display one, okay, which has a similar thing. Okay, I can just copy paste this thing here and say base class method one, something like that. Now this subclass can override display one because only the first function display is final, whereas the second method is not final. It is still can be overridden by the subclass. All right. And since I'm not using a final keyword, I can derive from it. So now if I run the program, of course, I have to use uh, display one here. Otherwise, if you just use display, see what happens. It will call the base class method because there is no subclass implementation. I am base class method. All right. So if you want to call the overridden method in the subclass, then it should be display one. Now you will see I am subclass and I am derived class method. There is a provision to limit the derivation. That is, if you want to make a class final, put a final keyword after the class name here, and derivation will be blocked. So this subclass cannot derive from base. And if you make the method final, you cannot override it. All right. So these are some of the finer details you should know when classes are derived from another class. All right. In C++, there is a new feature called as templates. Now let's see what is the need for templates and how we can create templates. Let's say we have a simple add function here, and we have an integer implementation of the same. All right. Now, if I want to add two real numbers, then I have to write a separate add method here, which is overridden. Both arguments are float, and you have to say return x plus y. And here in the main, I can display the sum of two integer numbers. This should work perfectly fine. And also, we can call the same add function with two real numbers. So if I run the program, you'll get two results, one for integer addition, another is for floating point number addition. So this is working perfectly fine, no issues. But why write the same logic for similar operation? You are just adding two numbers, and why write two times the same add function? So is there a way to get around this and write only one function which will accept both types of data? Okay, so that is possible through template function. So to convert these functions to template, write keyword template, and then within angle brackets you write type name and mention the generic type as capital T. So you'll be using uh, variable names like T, U, V, Z, like that, and this return type should be T, and the data type of first argument is of type T, capital T. This is also T. That's it. Now you don't require this. Okay, but then how does it understand to call different types? Okay, so here the generic type will be T. So depending on what data type you pass here, automatically it will be converted into that type of function. So you don't try to write these things two times. So the program would still work perfectly fine, as you can see now. All right. So I have not made any change here. Just single template function is working for both data types. Similarly, we can have squaring of a number template, again type T, and then you can have a function called as square it, or it should be type name, not type like that, type name. All right. So as you can see, I'm writing a square it function. Now, reason why I'm writing this will become obvious when I explain this. What is the problem with this function? If I say square it integer number, perfectly fine. A float number, perfectly fine. Okay, so we'll see that happening. If I have sent 4, I should get 16 as the answer. And if I sent 4.6, something like that, I should get appropriate answer there. So some real number like that. And if I sent a floating point number, there is no issue at all. Okay. Now, if I send string here, then what happens? Because this being generic, it should accept data of any type, but it refuses to find x into x because it is meaningless to say hello into hello. Okay, so there should be a specific type function available, and you can write it here. So the way to do that is, again, you say uh, template with empty angle bracket, and then you should say string. So this is called as template specialization. Then square it in angle bracket, again the data type of the data, within bracket again string x, and within this you should say return x. Now it's not meaningful to say x star x. It should be, when you send same string, you squaring that will be just concatenating the two. So you are redefining square it when it comes to a string like that. For this to work, you must specify the data type in angle bracket after the function name here. So string like this. So now if I run the program, the error would vanish and you will get the output. As you can see, it is concatenating hello with itself. These are template functions. Template classes are also available. Now, another thing is it is not that you can have only one data type here. You can have type name as U, and this Y can be of type U, and return type can be of type U here. It means X and Y can be of two different types. All right. So, for instance, if I say add 4 and 6.5, it should work fine. It knows that how to convert this case and give you 10.5. All right. So, template functions are very useful. You write it once and use it for any data type. One other very important application of this would be in sorting, where you want to exchange two data elements. So in that case, you can write a function like this, type name t, and let us say we have a function exchange. Just observe, exchange is not going to return anything. It's going to accept two values by reference, and within the body of it you should take a temporary variable t, and in t you pass a, and in a you copy b, and in b you copy t. So this is a regular exchange function. Now to demonstrate this, let's say we have two values here, int x equal to 5 and y equal to 7, and you can say cout before exchange x y x, and then little space, and then y and l. And now you call exchange function with x comma y, and since it is called by reference, the values of x and y would be exchanged. And if I display after exchange, let's see what happens. So before exchange 5 7, and after exchange it is 7 5. Even if I pass some double data type, it should work fine. Float here. So if I send a real data type, it should work fine. Okay. So as you can see, we can pass data of any type and get the exchange done, which is very useful when you're doing sorting, right? So to summarize, what all we have discussed is, whenever you have hierarchical derivation of classes, if any data member is protected, it is accessible to the subclass. But if it is an object, then that object's private member will remain private. Okay, so you should put getters or setters to either access the private data member or modify it. We saw what is the implication of final keyword with the class and final keyword with the virtual method. If I use final keyword with the class, then you cannot derive another class from it. So that class becomes final. Similarly, if I use a final keyword with the virtual method, you cannot override it. So those are the implications of use of final keyword. So templates functions allow you to implement function for different data types. So you don't have to write same function for different data types. A template definition starts with the template keyword, and then within angle brackets you write type name, and T should be used everywhere wherever you have a variable declarations. They can be regular variables or reference variables. And in certain instances, whenever the implementation of generic function is not possible, then you have to specialize that function. For example, in this case, square it is meaningful only when x values are either integers or real numbers. But for string, it is not meaningful. So for that, a specialization function has to be explicitly written with template empty angle brackets, and there you indicate clearly what this query is going to return and what is the data type of argument, and then you give a meaningful implementation. So squaring of a string would be meaningful just to concatenate the two strings and return. So the demonstration of the same, I have shown it here. All right. So more on template functions and template classes specifically, we shall see in our next lecture. Until then, bye. Thank you.